Hey, welcome back, PoA. Here is part 2, problem 2 of the unit review for the test that's coming up this Monday. Here we go. So to have a hope to do these problems well, you're going to have to know what a couple words mean. One of those words is expression, and the other word is, of course, evaluate. And if you have a sense of what these two words mean, then the problem becomes actually pretty simple. So let's talk about expressions. So what are expressions? Well, frankly, these are expressions. These are a grouping, it's not quite an equation, but it's a combination of terms, usually involving variables that you can't actually solve, but you can evaluate. Well, that means if these are expressions and we can't solve them, but we can evaluate it, well, what does evaluate mean? Well, evaluate means to do something very natural, something we train you to do in math all the time. Evaluate is, if you know the value of a variable and you see the variable somewhere else, the evaluation is a process in which you replace these things, like the variables, with the actual value you know. So if I were to evaluate x plus 4, and I know x equals 3, that evaluation would be putting 3 in for the x value, and then solving what I can, ending up with 7. That's what it means to evaluate. Like that whole thing is it's been evaluated. Okay, so if that's the case, it seems to me that what we have to do is for each of these expressions, find values for the things that we don't know, and then stick them in and solve them out. Like, I mean, that's really it. So the explanation of that, well, the wording of that's really up to you. So let's get to her, shall we? So we have x times a quantity, and that's what parentheses mean, quantity, y plus z. So we probably should find values for all this, and let's maybe just write it out. My sincere advice to you would be don't be lazy here. Go ahead and rewrite the whole thing just with the replacements, and put those replacements in parentheses. So we have this x, and I see x equal to negative 4. So instead of the x, I'm going to write a negative 4. We have this y plus z. Y is equal to 9, z is negative 2. So we're going to have a 9 plus a negative 2. So we just did a replacement xyz for the xyz's over here, which will be kind of standard fare for all four problems. Now it's just a matter of working it out. So we have this negative 4 on the outside. We have 9 plus negative 2 on the inside. I can solve that. 9 added negative 2 is going to end up being a 7. Well, now we have just 4 times negative 4, times a 7. That will be negative 28. 4 times 7 is 28. 1 negative, 1 positive makes the whole thing a negative. So again, just kind of reviewing the steps here, we're going to stick in the numbers we know for the variables, and then we're going to carefully work it out. And I'll be honest, where you're going to make your mistake, if you're going to make one at all, is going to be probably in the working out process. Especially if you do yourself a favor and put parentheses in for the things you exchange, you're gonna have to just be really careful and work slowly through the rest. Okay? So let's take a look at the second problem. Again, I'm going to transfer everything that's not a variable. So we have this 2. We have this x, which is going to be squared. And then we're going to have this y times z. So I'm kind of preloading with parentheses and all the spots of things I do have to exchange. So we have the x squared, which would go here. We have the minus y times z. So let's just replace. Here's that x. It's going to be a negative 4. And the negative does have to come with it. And it does go inside the parentheses. We have a y and we have a z. Let's recall y is equal to negative 9. Oh, no, excuse me, just a 9. And then z is going to be equal to that negative 2. Okay? So now let's go ahead and solve this out one step at a time. My advice again is to go slowly. We don't have to rush. You have plenty of time, plenty of paper. So order of operations, which is PEMDAS, indicates that we should do parentheses first. So I have this parentheses over here, so I'm going to rewrite the 2 times the negative 4 squared, subtract off what's going to go on inside the parentheses. Well, what's going on inside the parentheses is going to be a 9 times a negative 2. Again, let's do this in pieces. 9 times 2 is 18. 1 negative makes the whole thing negative. Okay, so that takes care of that much of it. Okay, so parentheses are done. We can move on to exponents. So I do have an exponent right here. So we're going to have 2 times whatever this is squared. Well, negative 4 squared, you're going to want to say like negative 16 because you're just thinking about negatives, but you have to recall what it means to square a number. So let me just zoom in right here for a second. If I have a number like 3 and I square it, what that translates into directly is 3 times itself because it's 2, okay, and the base is 3. So if I have like 4 to the third power, that's going to be 1, 2, 3 fours. 4 being the thing you're multiplying, that being how many times you're multiplying it. So if I have something like a negative 3 and I want to square it, that's going to turn out to be negative 3 times a negative 3. Now notice what's going to happen here, a couple things. One, you are still taking 3 times 3 and getting 9, but since you have 1, 2 negatives, the whole result should be positive. So that's what's kind of going on here. We have this negative 4 and we're going to square it. So that's like saying negative 4 times itself. So 4 times 4 does end up being a 16. A negative and another negative together make a positive. So overall we're going to have just a positive 16. Okay? Then we have this negative and a negative here, which we can resolve with this step as well. Excuse me. A negative and a negative. Now that's going to be kind of like multiplication, so we're going to say it's going to be a plus 18 instead. So we're reducing it. We're going slowly. We're going to go down one more step. We have a 2 times a 16. And that's going to equal a 32. And then we're going to have a plus 18. Addition comes last. Well, that's 30, 40, 8 and 2 make another one. So 30, 40, and that should be 50 for an answer. A fairly complicated problem, but one that you guys can definitely transverse if you go slowly. If you think about the key to this, I didn't try to do too much at once. Like I know it takes longer, I know it takes a whole lot more effort, but in the end, you're going to be better off simply because you are taking only one step at a time. Let me try to demonstrate again in this problem after I clean up all this craziness. Okay, so we have 12 divided by x minus z squared, so check it out. So 12 divided by some value x, putting this parentheses there for now, minus z squared. Okay. So now let's do some replacement. We have x as a negative 4, and we have z as a negative 2. Okay. So now we just have to continue our kind of journey here, and again, one piece at a time. PEMDAS says we need to do this first. So I'm just going to write the 12 divided by negative 4 and subtraction, and then let's take care of the negative 2 squared. Well, we're into the same problem we did last time. Negative 2 squared literally means negative 2 times a negative 2. Well, 2 times 2 is going to be 4. Negative and negative make a positive, so I don't have to write anything. Now this negative, and here's going to be a point of confusion, that negative does carry. So even though this negative 2 times itself is going to end up being a positive 4, since I have the negative from the problem, I should still have a negative in my existing problem. So the negative here was taken care of through the squaring, but this negative is still there because we haven't resolved it yet. So as we move forward to the next step, we have 12 divided by negative 4. Well, that's going to end up being a negative 3. 12 divided by 4 is 3. 1 negative makes a negative. Subtract off the 4. So 3 minus 4, that's like saying, hey, the temperature outside is like negative 3 degrees, and it's going to drop 4 more degrees. Well, now it's a negative 7 degrees. Okay, don't get confused or caught up in the rules about negatives making positives. Sometimes using a model is the best thing you can do. All right, the last problem. Again, replacement. Oh, yellow's back color, Mr. Collins. Let's try this one. So we have 3y parentheses, subtract off we have negative x minus 4, and then replace with a z, close. So now let's fill in numbers. And again, I'm just setting this up so it's a little bit easier for me to make sure I'm copying everything down. Notice the only thing I'm changing are the variables, and it's making the open parentheses. So we have 3y, and y is going to be 9. We have an x, and that's going to be a negative 4. And then we have a z, and that's going to be a negative 2. So that comes from our replacement. Now let's do this one piece at a time. We don't have exponents. We do have a whole lot of parentheses. Here's one set. We have 3 times 9. We'll make that a 27. Break parentheses for these parentheses right here. Maybe switching colors will help. Wow. Okay, so within the parentheses, let's do some resolution. We have a negative 4, which is going to be a 4. And then we're going to have a negative 4 times a negative 2. Well, again, here's an opportunity to break up the thinking into two different parts. 4 times 2 is going to be 8. A negative times a negative is going to be a positive. Okay. So now, again, we still have some parentheses to resolve. We still have this 27 from the outside. We do have 4 times 8, which is going to be, what's that, 4 times 8, which is going to be 12. Okay. So now you got to go to your calculator. I'm just going to work it out right here. We have 27 times 12. 7 times 2 is 14. C is 4, 5, 0, 2, 7. Uh, 4, 12, 3. So we should have 324. Okay. So that's the second question in the set. Again, I'm not going to think about the thing at the bottom. That's up to you. Just kind of thinking, keep in your mind what evaluate and expressions are, and how to. So that what that really means is just taking the variable values and sticking them in and then solving them out, and you're gonna be just fine in the test. So thank you for watching this. I'll be right back with part 3.